Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm now answering question number 10 from the June 2022 Pure Mathematics P2 International A-Level Edexcel exam. This is the last question on the paper, and it's about circles and equations of circles. It says the circle C has center x, 3, 5, and radius r. The line L has equation y equals 2x plus k, where k is a constant. Show that L and C intersect when you have this equation: 5x squared plus 4k minus 26 all times x plus k squared minus 10k plus 34 minus r squared equals 0. Okay, now we know if the circle has a center x, 3, 5 and a radius r, we know the general equation for a circle is x minus a squared plus y minus b squared equals r squared. And this is derived using Pythagoras' theorem, okay, which, we don't need to know the derivation, but you must know how to form the equation of the circle given the center and the radius. So in this case, the center is basically AB. Okay, if the center is AB, this is, and the radius is R, this is the equation of the circle. X minus a squared plus y minus b squared equals r squared. X minus the x coordinate of the center all squared plus y minus the y coordinate of the center all squared equals the radius of the circle squared. That is the equation of a circle. So in this case, our center is 3, 5. Our center is 3, 5. Okay, so our center is 3, 5, and the radius is r. So we're going to say the equation of the circle is x minus 3 squared plus y minus 5 squared equals r squared. Now we want to see where the line y equals 2x plus k, we're going to show that they intersect at this point. So how do we know how do we find the point of intersection between a line and a circle, or between two lines, or between two circles, or two curves in general? How do we find where they intersect? We basically substitute one of the equations into the other. So what I'm going to do is I'm going to replace the y in this equation. So I'm going to replace the y here with what y is equal to in the line, and that will give us an equation which will tell us where they intersect. So what I'm going to do now is I'm going to write this as x minus 3 squared plus, instead of y, I'm going to put 2x plus k minus 5 squared equals r squared. So the y was replaced with 2x plus k. Why is that? Because y is equal to 2x plus k. Okay, then we have an equation which just has x's in it, which is what we require, and no y's in it. And so hopefully when I expand this and simplify it, that should be what I get if we've done everything right. So what I'm going to do is I'm going to think of this as, to make life a bit easier, I'll think of this as a constant, as one kind of constant, and I'll treat it like one bracket. So 2x plus k minus 5 is like the number. Okay, so when I expand the brackets, it will make life a bit easier for me. So here I have x minus 3 squared, which expands. If you expand this, you're going to get x squared minus 6x plus 9. Don't forget, okay, x minus 3 squared. Okay, one of the common errors is to write down x squared minus 9 or x squared plus 9 or something like that. No, there's going to be a middle term. This means x minus 3 multiplied by x minus 3 gives you x squared minus 6x minus another 6x plus 9. Or we can think of it as we square the first term, and then we have the minus, so there's going to be minus, then we have 2 times the first term times the last term, and then always plus the square of the last term. So you end up with x squared minus 6x plus 9. Okay, and so I'm going to do a similar thing here. I'm going to square the first term, so that's going to be 4x squared. Don't forget to square the 2 as well as x. And then I'll have 2 times, so I'll have plus 2 times the first term times the second term, plus, then I'm going to square the last term, so it'll be k minus 5 squared, and that will equal r squared. So let's see how that simplifies. So let's just try to combine what I can combine first. I've got x squared plus 4x squared. So that's 5x squared. So I've dealt with those two. Then I've got minus 6x plus 9. Well, there's nothing I can do with that right now. Let me just simplify. That's going to be 2x, 2 times 2x, which is 4x, 4x times k, which is 4kx, and k is a constant, so I'll write that first. And that's 4x times minus 5, which is minus 20x. And then I'll have plus, and if I expand this bracket, I get k squared minus 10k plus 25. Now be very careful not to write your k as an x. These are x's, those are k's. Okay, it's very easy to mistake a k for an x, and especially when you're writing quickly and maybe not neatly. All right, so I've got 5x squared. That's fine. Then I've got minus 6x minus 20x plus 4kx. So I can write that as plus 4kx minus 26x. So I've dealt with this one, and this one. Then I'm going to have k squared plus k squared minus 10k. And then I'm going to have 9 plus 25, which is plus 34. And I can say minus r squared equals 0. So you can see that I'm almost there. I've got my 5x squared, I've got my k squared minus 10k plus 34 minus r squared. It's just this thing here that I've got to sort out, and I can see what they've done is they've taken x as a factor from these two terms. So that's what we're left to do. So we have 5x squared plus, and we can write this as 4k minus 26 times x. That'll give me 4kx minus 26 as we have there, and the rest is as we have it, k squared minus 10k plus 34 minus r squared equals 0. As required, that's exactly what we had to show, and we've shown it. So that's part A of this question done. Then it says, given that L is a tangent to C, show that 5r squared equals k plus p squared, where p is a constant. Now, if the line is a tangent to the circle, okay, then there will only be one intersection. When you have a circle and you have a line, okay, when the line intersects the circle in 2 points, at 2 places, there will be 2 solutions to the equation which gives us the intersection. So this is the equation that gives us the intersection, and we know that there's not 2 solutions, there's not no solution, there is one solution. It's called a repeated root, one solution, where the tangent touches the circle. The tangent just touches the circle. So where the line L touches the circle, there will only be one solution. So this equation has one solution. So we can say that the equation, okay, 5x squared plus 4k minus 26x plus k squared minus 10k plus 34 minus r squared equals 0 has one solution. Okay, has only one solution. Okay. So therefore, we can say the discriminant is equal to 0. So we can say b squared minus 4ac must equal 0. If there's 2 solutions, then b squared minus 4ac will be positive. If there's no solutions, b squared minus 4ac will be negative. If there's one solution, a repeated root like we're going to have, then b squared minus 4ac is going to equal 0. So we know that in this equation, remember, in a quadratic equation which we have here, you have ax squared plus bx plus c equals 0. This quadratic equation is formed, but when we try to find the intersection between those two, we can see that a is the coefficient of x squared, b is the coefficient of x, and c is the constant, which is all of these together. Okay, r is a constant, it's the radius, k is a constant, and so on. So we can say that a is equal to 5, and b is equal to 4k minus 26, and c is equal to all of that, k squared minus 10k plus 34 minus r squared. So we can say b squared minus 4ac is equal to 0. So 4k minus 26 all squared minus 4 times a, which is 4 times 5, times c, which is k squared minus 10k plus 34 minus r squared equals 0. So now hopefully this will simplify to something that looks like that, where we got to find p. Okay, so now what I'm going to do here is I'm going to do something, actually it's not, I can just do this. This is going to be 4k all squared minus 4k, 2 times 4k times 26. This is using the pattern of a squared bracket. So 2 times 4k times 26, and I'm going to have plus 26 squared because it's going to become positive. All right, so you square the first term. There's a minus, I'll put a minus, and I do 2 times the first term times the last term. Okay, and then I square the last term. Okay, minus, and there's going to be 20 times k squared minus 10k plus 34 minus r squared equals 0. So let's simplify this. 4k squared gives you 16k squared. That's going to give you minus, that's 8 times 26. I think I need the calculator for that. So you have 8 times 26, which is 208. So that's negative 208k plus, and then you're going to have 26 squared, which gives us 676. Okay, and then you're going to have minus 20k squared plus 200k minus, that's 2 times 34, 68, minus 680, and you're going to have plus 20r squared equals 0. Okay, so now let's see what happens. This is 26 squared. Okay, so now we're going to have, we got here 16k squared minus 20k squared, which is minus 4k squared, minus 208k plus 200k, which is minus 8k, and we have 676 minus 680, which is minus 4, and then we got plus 20r squared is equal to 0. Now I can see each of these terms is divisible by 4. Each of these terms is divisible by 4. So I have minus k squared minus 2k minus 1 plus 5r squared equals 0. This looks a bit promising now because we have to show this. So let me just keep the 5r squared here and add each of these terms to both sides. So plus k squared plus 2k and plus 1. And this is a perfect square. If you factorize this, you're going to get k plus 1 squared. If you square this bracket, you get k squared plus 2k plus 1. And we have shown what we had to show. Okay, and that is that. Okay, so that's part B done. All right, so we basically took the equation that they gave us. So again, this is the type of question where if you have some sort of a problem, okay, with understanding part A or finding this, showing this, but you understand how to use this equation which tells us where they intersect in answering part B, you understand the discriminant has to be 0 of this equation that we had to show. You couldn't show this, so you lose the 3 marks or maybe some of the 3 marks. But, or even if you knew what to do and you didn't get it somehow, you messed up with some algebraic manipulation, but you have what you need to answer part B. If you understand how to do part B when there's a tangent, there's one solution, then you can do part B. All right, and you have, you have not lost those 3 marks. So they're making the question such that now not knowing how to do the first part doesn't necessarily mean you can't get the marks for the second part. So never ever look at part A or try to do part A and say, oh, I couldn't do it, so forget it, and don't even look at the rest of it. No, you always look at the other parts of the question. There's always going to be an opportunity for you to salvage some of the marks. So that's part B done. Now we're going to move on to part C. Now, part C, they've given us the diagram now. They've given us the line. That's a tangent to the circle. There's the center of the circle. This is what we had to just show. 5r squared equals k plus, now we found the p is equal to 1, so we put k plus 1 squared. And then it tells us the line L cuts the y-axis at the point A and touches the circle C at the point B. Okay, as shown in figure 2. So given that AB equals 2r, find the value of k. Now what I'm going to do here is I'm going to, how do we deal with a question like this? Well, just write down what they've given us. They've told us that, this is the radius. Okay, this is the radius, this is r, and AB is 2r. Now what that should make you realize is something, that the tangent and the circle, okay, the tangent and the radius of the circle, where they touch on the circumference of the circle, there's a right angle formed between them. Now that right angle there is going to help us because it forms a right angle triangle. Okay, and we can now use what we've just done to try to figure out some stuff. For example, I can say that the AX, okay, or the square of AX is equal to the square of 2R plus the square of R. So AX squared, we can say, is equal to 4R squared plus R squared. Okay, so we can say AX squared is equal to 5R squared. And we see we have a 5R squared there. And we know something about A. We know that the y-intercept of A is at the point, the y-intercept of this line is 2x plus k. So A has the coordinates 0 and k. Okay, it cuts the y-axis at point A. So that means A has the coordinates 0, k. So I can now have an expression for AX. I can say AX squared is also equal to, if I now use the length formula, I can say it's going to be the change in x, which is 3 minus 0 squared, plus the change in y, which is 5 minus k squared. So I can say AX squared is equal to, that's going to give you 9 plus 5 minus k squared, which I can expand later if I need to. So that helps us now to solve the problem, because we have an expression for AX squared. We have this expression for AX squared, and we have this expression for AX squared. Okay, so we can say that AX squared equals 5R squared. So we can therefore say that 5R squared is equal to 9 plus 5 minus k squared. And we also know 5R squared equals k plus 1 squared. So basically what I can do is I can say this and this are equal to each other. Okay, so we can see that 5R squared, as we were given in the question, 5R squared is equal to k plus 1 squared. We found that in part B. Okay, we were supposed to show that. Even if we couldn't find it, we can use that, of course, now. And we also know that 5R squared is AX squared, which is equal to 9 plus 5 minus k squared from the length formula. So I can now say that these two are equal to each other. Okay, because they're both equal to 5R squared. So I can write that k plus 1 all squared is equal to 9 plus 5 minus k squared. So if I expand this and expand that, and I'll have an equation that I can solve. This is going to give me k squared, because the only unknown here is k. So k squared plus 2k plus 1 equals 9 plus, this is going to be 25 minus 10k plus k squared. When you square this bracket, square the first term, multiply them together and double it, and then square the last term. Okay, so now you can see if I try to bring the k squareds together, they're going to cancel out. K squared minus k squared is 0. So I'm left with 2k minus 10k. Well, I'm going to add the 10k to both sides. So that's going to give me 2k plus 10k. And on this side, I'm going to have 34 and minus 1. So I'll have 12k equals 33. So k, therefore, is 33 over 12. And I can divide both of them by 3. So k is 11 over 4. So that is the answer. That is the value of k. Okay, so there's a bit of thinking involved here, where you have to just use the fact that the radius and the tangent meet at right angles, and the length from A to B is 2r, and the length from B to the center is r, of course the radius, and we can use that to make an expression for AX, okay, which is basically AX squared equals 5R squared, and we'll notice that 5R squared is also equal to k plus 1 from what we got in the previous question. So we know AX, the length between AX is given by the length formula. All right, I didn't write the square root because I want it squared. So you got 3 minus 0 squared plus 5 minus k squared equals AX squared, and that's equal to 5R squared. So you can equate that expression to what we found earlier, and you get your answer. Okay, so that's quite a few marks there, 6 marks. So it's a bit. You have to think a little bit, but a few things you should be brainstorming. The radius and the tangent meet at right angles. A right angle, okay, that helps us to understand. Okay, we can make a right angle triangle. Pythagoras theorem applies, and so on, and we can deal with the question. So that concludes this question, which is question number 10 from the June 2022 International A-Level Edexcel paper. Other questions from this particular paper can be found in the playlist the link will be over here somewhere at the end of the video. Also, you'll have a link over here taking you to questions dealing with equations in circles from P2. You can subscribe to my channel by clicking on this link in the middle. Thank you for watching. I hope you understood everything fine. Other material you might want to watch from A-Level and AS and from IGs, you can find in the description. There will be some links there for you to click to find those. Thank you for watching and see you soon.